Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. Now, I gotta apologize to you up front for this video. I had a little bit of issues getting videos cut and made and everything. So what I ended up having to do was to take a piece of another video, break it down, and basically that's why the numbers today are going to be a little bit weird. For example, we're starting with number 9 instead of number 1. I'm sorry, it's the best I could do. You'll notice in the video I referenced being up late. I think I recorded that one at somewhere around midnight last night. And so anyway, it's the best that we can do in the moment. That's one of the benefits of this whole distance learning thing, is that I can record something yesterday and you guys can watch it today. And yeah, that's it. Let's go ahead and get into it. All right, inscribed angles. Okay, an inscribed angle, I'll let you read that if you want to, but here is the basic idea. Here we have an intercepted arc, which is QS, the one that's being intercepted by the two endpoints of the angle. Earlier in the unit, I guess it was last lesson, we talked about central angles, where the vertex was over here at the center. Now we're going to talk about another angle that is over here on the circle edge. That is an intercepted arc with an inscribed angle. Now, what you need to know about the inscribed angle is it doesn't matter where on the circle it is. I could put it over there. This is still over here at point, I already have an S, over here at point T. That's still an inscribed angle. I could also put another point down here, Z. That's an inscribed angle. It doesn't matter where on the circle I place the inscribed angle, or the vertex of the inscribed angle, the properties I'm about to show you in the next slide are going to hold true. So, when an angle is inscribed in a circle, so here we got angle E is inscribed inside the circle, then the measure of the inscribed angle equals exactly 1/2 of the intercepted arc. So here angle E is going to be exactly 1/2 of arc DF. Now that's simple enough, because all that tells me is that if angle DF, let's just throw out a number here, is, don't want to use a highlighter, I'm going to use a pen, is 100 degrees, then angle E must be half of that, which is exactly 50 degrees. Okay? Works the other way around. If angle E is 50, then angle DF is 100. Now, like I said earlier, it doesn't matter where on the circle I place the inscribed, or the vertex. Let's draw, call this point H over here. You'll notice whenever you look at this that DF is my intercepted arc. Now, angle E is inscribed inside of that angle, or is the inscribed angle. We also know that H is now also an inscribed angle, and they both intercept the exact same arc. Therefore, this must also be 50 degrees. Anytime that two inscribed angles intercept the same intercepted arc, then those two angles are going to be congruent to each other. So angle E is congruent to angle H, and you'll notice this little kind of hourglass figure, kind of like the Black Widow logo that we've got going on there. Let me go ahead and change this one over to green. This hourglass. Anytime you see those, you know that those two angles, E and H, are going to be congruent. We also know that D and F are congruent to each other as well, because they intercept this angle over here. That'll make more sense as we go through them. And my ink color, let's do it in purple now. Okay, find the measure of angle X. Looks like angle X is my inscribed angle on the right. It is an inscribed angle, and it intercepts arc ZW, which is 86 degrees. Therefore, the measure of angle X is equal to 1/2 the measure of arc ZW, which is 1/2 times 86, which, hey, I can't do that one in my head. That is 43 degrees, just cutting it in half. Okay, find the measure of arc XY. Well, here we got inscribed angle Z, intercepted arc ZX, or XY. So 1/2 of arc XY is equal to the measure of angle Z, Z. So whenever I plug that in, 1/2 times XY is equal to 52 degrees. We're going to multiply by 2, and X, the measure should have a measure there. Measure of our XY, double that gives me 104 degrees. Simple enough. All right, let's jump over and do one of those hourglass figures. Now, over here, we've got angle R and angle S. Now, if I follow S over, it's going to intercept arc TQ. And also notice the angle R also intercepts TQ. What that means is those two angles must be congruent to each other. So 12x minus 13 equals 9x plus 2. Solving on both sides, we're going to subtract 9x, gives me 3x. Add 13, gives me 15. Therefore, x equals 5. Don't take the bait, we're not done yet. If x equals 5, measure of angle R. Measure of angle R is equal to 12 times 5 minus 13, which is 60 minus 13, which is 47 degrees. All right. Example 12, another one of these hourglass figures. So we know that, let's see, we know the measure of angle A and the measure of angle C. Let's start with angle A. Angle A, its intercepted arc is BC. Now we also know that D also intercepts arc BC. So that must mean that the measure of angle A equals the measure of angle D. So 6y minus 2 is equal to 5y minus plus 8. Let's solve. Subtract 5y on both sides gives me y. Add 2 to both sides gives me 10. Now let's plug that back in. Measure of angle A is equal to 6 times 10 minus 2. 16 minus 2 is 58 degrees. We also want the measure of angle, this one in red this time, measure of angle C. Angle C intercepts arc AD, and so does angle B. Again, those are equal. 6x minus 3 equals 7x minus 11. Subtract 6x on both sides gives me x on the right. Add 11 on both sides gives me 8 on the left. Then I want to do the measure of angle C is equal to 7 times 8 minus 11, which is 56 minus 11, 56, which is going to be 45 degrees. All right, I'm getting close to the end here. Inscribed angles. Sorry, inscribed polygons. Now, there's actually a lot going on inside this picture. Two separate concepts that I've consolidated in one image. These two concepts do not necessarily have to go together, but I want to go ahead and show them to you at the same time, just to keep things nice and concise. Okay, an inscribed polygon is one whose sides are chords of a circle and whose vertices are points on the circle. So basically, this inscribed polygon, A, B, C, D, all 4 points are on the circle. Now, there's several things you need to know, especially about inscribed triangles and inscribed polygon or inside quadrilaterals. Okay, so if an inscribed angle of a triangle intercepts a diameter, so here let's focus on triangle BCD. Okay, notice that angle C, its intercepted arc is arc BAD, which is a semicircle. Okay, important here, the thing is that BD is a diameter. Well, this over here is going to equal 180 degrees. So arc BAD is 180 degrees, which means that the intercepted arc, the inscribed angle is exactly half of that. Therefore, angle C must be a right angle. The exact same concept applies for angle A over there. So that since this side over here, arc BCD, is also 180 degrees, then we know that angle A is also 90 degrees. You're going to see this picture drawn quite a bit, where we have a diameter drawn, a little pokeball going on there, and then if I draw an inscribed angle off of that, this has got to be a right angle. Let's pretend I actually hit the center there, or hit the edge of the circle there. Okay. Now, the other thing that you need to keep in mind is notice what ended up happening with these two arcs, or opposing arcs, that I gave you. Over here on the left, this side was 180 and this side was 180. Notice that's going to happen no matter whether it's a diameter or not. Okay, let me do this in dark blue. Let's use my other two. So let's use arc AC and then arc ADC. See, it still encompasses one or the entire circle. What that means is that since opposing arcs equal 100 or equal 360 degrees, that means that the opposite angles in an inscribed quadrilateral are going to equal 180 degrees, because the inscribed angles are half of the entire circle. So the measure of angle C plus the measure of angle A have to equal 180. Also, the measure of angle D plus the measure of angle B have to also equal 180 degrees. So, two important things off of this slide. First one is this up here, that if a inscribed angle intercepts a diameter or a semicircle, then it is automatically a right angle. And also this down here, opposite angles in inscribed quadrilateral are supplementary, add up to 180 degrees. All right, let's take this down to the application level because it makes a little bit more sense that way. Here, WX is a diameter and Y is an inscribed angle. That means Y must be a 90-degree angle. Now what that tells me is my other two angles inside a right triangle must also add to 180. Add to 90. So X plus 12 equals 90 degrees. So 2x equals, subtract 12 gives me 78 degrees. Then divided by 2 gives me x equals 39. Well, therefore the measure of angle W equals 39 plus 12. 39 plus 12 is going to be 51 degrees. Okay, example 14. Now, we're going to use that property we talked about earlier, opposing angles. Okay, let's focus here on angles R and P. Angle R intercepts arc QPS. Angle P, if I go across, intercepts angle QRS. Together they intercept the whole circle, which means since they're inscribed angles, there have to be half of that. They're supplementary. So we know that 75 plus 3x is equal to 180. Subtract those off. 180 minus 75 gives me 105. Divide that by 3. X equals, grab my calculator just in case. I think it's 35. 105 divided by 3 is, yes, 35. Now, to find the measure of angle R and the measure of angle S. Measure of angle R is equal to 3 times 35. So, measure of angle R is 105 degrees. Measure of angle S is equal to 2 times 35. So the measure of angle S is equal to 70 degrees. I just realized I did that the hard way. Let me show you the easy way here. Shift over to a different color. Get rid of some of this stuff over here. Okay, since these two are supplementary, those two are supplementary, all I know is that the measure of angle R is equal to 180 minus 75. It should be a minus, which is just 105 degrees. Same logic applies for the other one. So sorry about that. Did it the long way. Okay. We want to find the measures of angle W and angle X. Very similar logic to the one before it. We know that angle X and angle Z are supplementary. So 3y minus 7 plus 3y plus 1 equals 180. So that gives me 6y minus 6 equals 180. Now we're going to add 6 on both sides. It gives me 6y equals 186. Divide through 186 divided by 6 is 31. Now, let's go ahead and plug that in to find the measure of angle X. So measure of angle X is equal to 3 times 31 minus 7. 3 times 31 is 93. I don't know why that spot doesn't like it every single time. 93 minus 7, and 93 minus 7 is 66 degrees. Now, we know that, again, W and Y are going to be supplementary. So X plus 18 plus 2X equals 180. Combine like terms gives me 3X. Subtract the 18 on both sides gives me 162. Divide through, and oh man, my mental math is failing me again. 162 divided by 3 is 54. Now for the measure of angle W, that equals 54 plus 18. And yes, I'm going to type in 54 plus 18 in the calculator because it is now midnight. Oh, see, I can't even type right. Plus 18 is 72 degrees. Measure of angle 2, I did that again, man. Measure of angle W. There we go. Well, that's all I got for you today. I hope that you guys now feel like you are complete experts on inscribed angles. Not really. I hope you guys got a little bit out of it. Do the practice problems, do the online quiz. You guys will be fine. Hey, COVID's going around. Stay safe, stay healthy, stay patriotic.